This is Mrs. Johnson. This is DCC MAT 223 Calculus 3. More examples from section 9.1. Example 4. Find the equation of the set of all points equidistant from the points A and B given here. In other words, we want to know the equation of all those points that are going to be right down the middle of points A and B. So we know if point P is a point equidistant from A and B, then P is the set of all points such that the distance between A and P and B and P will be equal to each other. So I'm going to find what AP and BP are, where I don't know point P. I just call point P X, Y, and Z. So if I call point P X, Y, Z, where I'm trying to figure out what X, Y, and Z are, then I would put it into the distance formula here, and it would be X minus -1, which would be this, Y minus 5, Z minus 6. So I'm putting it into the formula where P is X, Y, Z, and A is 1, 3, 1, 5, 6. I get this equation. Now I'm going to find another equation for BP, which is between the point P, X, Y, Z, and B, which is 3, -1, -4. Putting it into my distance formula, I get this. Now, if I want P to be equidistant, or equal distance between A and B, I have to set them equal to each other. So I'm going to set these two equal to each other. And when I take this, when I square both sides, I get this expression. Now we have to do a little bit of algebra here, or I should say a lot of algebra here. Foiling each one of these terms, we get, foiling this term, we get this term. Foiling this term, we get this term. Foiling this term, we get this term, and so forth. Foiling this, we get this. Foiling this, we get this. Foiling this, we get this. So a lot of algebra here. Now, we can cancel terms out. Notice there's an x squared on each side of the equation, a y squared on each side, and a z squared on each side. So we can cancel from one to the other when I subtract from both sides they will cancel each other out. Now let's combine like terms. We have a 2x and a -6x. So when I bring this to the other side, I'll have a positive 8x. When I have a -10 and I'm going to bring over the 2, that will bring me a -12y. And I have a -12z, and then when I bring the 8z to the other side of the equation, I'll get a -20z. Now let's bring all the numbers to the other side. So the 1, the 25, and the 36 I'll bring to the other side and combine like terms, and I get this. I get 8x minus 12y minus 20z is equal to 36. This equation is the equation of the surface that is equidistant between these 2 points. We're going to come to find out this is actually the equation of a plane. But it is the equation, because that's what they were asking us for, of the equation of all points. So any point that x, y, z that will make this true will be equidistant from A and B.